Alrighty, welcome. We're going to take a look at our next mini lesson on Chapter 7.2, Ratios and Similar Polygons. And to start off, we need to clarify and make sure we know these two reasons why things can be similar. First of all, corresponding angles must be congruent. Absolutely a must. And corresponding side lengths are proportional, again, another must. Proportional means basically they are equivalent ratios. So let's go ahead and take a look at our first example. This is number 10 on page 465. Now, the instructions are basically determine if the two rectangles are proportional, and if so, write a proportionality statement. This is not a proportionality statement right here. I could have wrote these rectangles as BCDA and JKLM or MLKJ. I could wrote them in any consecutive order that I wanted to. This is not a similarity statement. So let's take a look. I want to compare apples to apples, oranges to oranges. Well, in a rectangle, we have a short side and a long side, so I'm not going to compare apples to apples. I'm going to compare that to that, and this to that. And I better get a proportionality statement. Now, my writing pad has been temporarily fixed. I still probably buy a new one this weekend, I think. But we got 36 over 54. Now, there is more than one way to write this proportionality setup. I could have reversed it. I could have flipped these things. There's about 3 good ways to do it. There is some bad ways to do it. Like, for instance, I don't want to compare 18 and 54. So I'm going to take a look at this. Basically, I'm going to simplify the fractions on a problem like this. I know 6 goes into both of these, so that's going to be 3/4. And 6 goes into both of these, but that's not going to be the most simplified form. That's going to be basically 6 over 9, which can be simplified to 2/3. 18 goes into both. 18 goes into that 2 times, 18 goes into that 3 times, so I got 2/3. Well, obviously, I do not have a similar situation here. The angles may be all correct because we have right angles everywhere, but the side lengths are not proportional. Now, what if you had a question like this? What would make, say, this side right here proportional? Well, this would have to be something right here, this similar thing. Well, think about 6, is common here, 2/3. If that had to be something, we'd have to make that equivalent to a 3/4. So let's say 6 went into that 3 times, 6 went into that 6 times. So we would have to change that to basically 48 to make this proportional. All right. And then we could write our similarity statement if we had something like that. Alrighty, moving on. All right, let's take a look at number 20 on page 466. The instructions are simply find the value of x, and we are given that they are similar. That right there, we're told they're similar. That means that this is a proportional statement, a similarity statement. And we are given this triangle and that triangle. The important part of the information is right here. This is the most important piece of the puzzle. Now, one of the rookie mistakes that people make is they want to put x plus 5 equal to 30. That is a no-no. These are not congruent triangles. They're similar. So do not set that equal to that. Big no-no. We're going to set up a proportion. Now, I'm going to look at MP, and MP is right here. That is similar to XZ. So I'm going to put x plus 5. I'm going to try and write neatly. Again, my writing pad is not the best lately. It got squished. And I'm going to put that over 30. And here's my proportionality statement, or setup. And I have Pn. Here's Pn right here. And that's proportional or similar to YZ. YZ right here, 75. So apples to apples, oranges to oranges. Now what I did was I did a certain setup. You can do it differently. There's more than one way to solve these problems. I went from this triangle to that one. I had basically an arrow going like this. I set up my proportionality with this proportional to that, that proportional to that, so on. You could have done it backwards. You could have done it upside down. You could have compared these two and these two. There's more than one way. So let's go ahead and solve this puppy. I'm going to cross multiply using my cross products property. So I got 75 times x plus 5 is equal to 30 times 4x minus 10. all I did was just cross multiply. That's a property that we discussed in the previous chapter. It's just a short, quick way of using our reciprocals or inverse properties, stuff like that, for multiplying fractions. And here we go. I got 30 over here, 75 over here. I don't like big numbers. I'm actually going to divide by, it looks like 15 goes into both of them. So I'm going to divide both sides by 15. So I divide both sides by 15 because I don't have a calculator handy. You guys with calculators, knock it out. So that just turns into a 5 times x plus 5 is equal to 2 times 4x minus 10. All right, distribute. So you got 5x plus 25. I'm trying to write neat. And this is just back into your basic algebra, 8x minus 20. I'll do some shortcuts here. So I'm going to subtract 3x on both sides and add 20 over here. So I got 3x is equal to 45. If you did not follow that, go back and study some algebra. And then we got, of course, x is equal to 15. All right. You're going to want to pause, rewind, and look at this. But the most important part of the problem was right here. Okay, this setup. We were told the similar. Make sure you do apples to apples, oranges to oranges. Alrighty, I have another example, a little bit more complex, more on level of what we want you to do for the next lesson.